All right, we're going to talk a little bit more about the limit laws, and in particular address the part about just plugging in the value at which you're taking the limit to get the answer for the limit problem. And so you may have noticed in all of the previous videos that we did in this section, you could find the limit of a function just simply by plugging in this number a into f of x. The limit laws sort of always kind of amounted to doing that. And so the natural question that people ask is, hey, does it work that way all the time? And the answer is no, it doesn't work that way all the time. So, but it is true for a lot of different functions, in particular for a lot of functions that we care about in this class, and maybe that you will care about in other applications of calculus like engineering and things like that. So not every time it works that way, but for a lot of functions it does. And it's really the limit laws that make that possible, together with a property of functions called continuity that we will talk about in a later section. So let's just take a look at the functions that you can do this for. Okay, and so here this lists out a bunch of classes of functions that we can evaluate the limit just simply by plugging in. And so the first one we've already talked about before. If p of x is a polynomial, then the limit as x goes to a of p of x, you can get the limit just by taking a and plugging it in for x, right? That's what this represents here, p of a. So just plug in the number. For a polynomial, it's that nice. For sine and cosine, things always work that way, so those are nice. Notice here the other trigonometric functions aren't listed here, right? There's secant and cosecant, tangent and cotangent. They don't always work that nice. So, but sine and cosine, they do. Remember also that those other trigonometric functions like tangent is sine over cosine, right? So as long as the bottom part, the cosine, is not in zero, then you could evaluate tangent using the limit laws. So it's the issue is where the tangent and secant and cosecant, and where they're undefined. Sine and cosine don't have that problem. They're defined everywhere, right? Their domain is all real numbers. You can plug in any number you like in for x into either of these two functions and get a valid output for those. And it turns out that in terms of the limit, that's all you really have to do to take the limit of those two functions there. E to the x is another function like that. The limit as x goes to a of e to the x, the exponential function, right? You can find that limit just by plugging in the number a into the function and find the limit that way. And also for any exponential function that looks, some number to the x power like that. So in calculus, we tend to stick with e to the x for some reasons that we'll get into later. For calculus, it's the best exponential function. So, but that works nicely in terms of the limit. E to the x's inverse function, the natural logarithm function, ln, works that way for any number in its domain. So if the natural log function's domain is all positive numbers, so as long as you're taking the limit at a number that's in the domain of ln, then all you have to do is plug in the final limit. So again, in calculus, we tend to use the natural log as opposed to the other logarithm functions for reasons, like I said, we'll get into later. Likewise, the inverse tangent, the inverse trigonometric functions, right, are also like that as well. If I want to take the limit as x goes to a of inverse sine, all I need to do is plug in here. And same thing for cosine, and same thing for tan here. So, and that's most of the functions which we would care about in calculus class. Are those functions there. So pretty much for any of the major classes of functions that we want to look at, for a lot of them, you can just take the limit evaluating the function. That is, taking the number a and finding the function value there, that's going to wind up to be the limit. So that's kind of nice. So, so there are situations that we will run into where it won't be that easy to find the limit, and so that's what we will talk about next. What do you do when you have a situation where the limit laws don't apply and I have different functions than what I have here?